What if the silence of the universe is not a beginning but an echo? Silence not of emptiness, but of civilizations that have already burned bright and disappeared, leaving no trace in the night sky. In the middle of the 20th century, during a casual lunch at Los Alamos, the physicist Enrico Fermi raised a question that would haunt science for generations. If the galaxy is filled with stars older than our sun, with planets orbiting them in abundance, then where is everyone? His puzzle became known as the Fermi paradox, the contradiction between the vastness of the cosmos and its unbearable silence. Decades later, thinkers like Robin Hanson would give that silence a darker shape. He proposed the Great Filter. The idea that somewhere along the path from lifeless rock to spacefaring civilization lies a barrier, a stage that almost no species survives. Perhaps it is behind us, perhaps it waits ahead. But the paradox does not only belong to the stars, it points back to Earth itself. If intelligent life is so rare, could it be that we are not the first to rise here? Could time itself have buried the memory of an older civilization beneath layers of stone and ocean? In 2018, NASA scientists Gavin Schmidt and Adam Frank dared to ask that very question. They called it the Silurian Hypothesis. If humanity vanished today, what would remain after 10 million years? Would our skyscrapers endure? Our satellites? Or would all evidence of us dissolve into dust, leaving only subtle chemical scars in the rocks? The silence of the cosmos may not only be out there, it may also be under our feet. The silence of the stars is unsettling, yet the silence of the earth may be even more disturbing. If the traces of a prior civilization once lived upon this planet, then the ground beneath us should remember. But geology is not a faithful historian. It is a merciless eraser. Geological time moves like a slow tide. Mountains rise only to be worn into sand. Oceans consume the continents and birth them again. Entire landscapes vanish as tectonic plates slide beneath one another, their histories carried deep into the mantle. What feels permanent to us? A city skyline, a monument carved in stone. Even the bones of our species is fragile when measured against the patience of the earth. This realization strikes with quiet terror. If something intelligent had existed before us, its remains may have been swallowed whole. No ruins, no libraries, no monuments. Just dust, pressed into rock, hidden under miles of shifting crust. The shock is not in the possibility of their existence, but in the absence of certainty. Fossilization itself is rare. The vast majority of life that has ever walked this planet leaves no mark at all. Most creatures dissolve into soil, recycled by microbes in time. Even the great bones of dinosaurs, titans that ruled the earth for over 150 million years, are found in fragments. Less than 1 in a billion organisms is ever preserved as a fossil. If these colossal beings, spread across entire continents, are reduced to scattered remains, then what of a civilization built of fragile bones and perishable tools? Even the artifacts of humanity which feel so enduring are not designed to last. On geological scales, skyscrapers would fall within centuries as steel corrodes and concrete crumbles. Bridges would collapse, roads would vanish beneath vegetation, and the glass windows of our cities would turn to dust. Within 10,000 years, most human structures would be gone. Even our satellites, silent watchers above the planet, are not immune. Atmospheric drag will bring them down within a few centuries. The International Space Station, orbiting overhead as a symbol of human ambition, will one day burn in the atmosphere. Even the higher satellites, circling in geostationary orbits, are vulnerable to collisions and decay. On cosmic timescales, they are fleeting sparks. Plastics, the artificial signature of our age, may endure longer. Some studies suggest they could last for hundreds of thousands, perhaps millions of years, altered into strange forms within sediments. Yet even these markers are not guaranteed. Geological recycling may fold them into new rock, melting their signal into obscurity. Nuclear isotopes, born from our experiments with fission and fusion, might leave chemical fingerprints in the strata. Uranium, cesium, and plutonium could serve as silent witnesses to our time. But even these traces fade. As radioactive elements decay and layers of earth are subducted. After 10 million years, most isotopic evidence could be erased, just as the memory of volcanic eruptions or ancient asteroid strikes is blurred in the rock record. This is the scientific shock. Humanity may be building what feels like a permanent world. Satellites in orbit, cities of steel, a digital cloud of knowledge, yet when placed against the canvas of deep time, permanence dissolves into illusion. Our entire civilization could one day vanish without a trace, indistinguishable from the silence of the rocks. The human ego recoils from this. We believe ourselves unique, destined to endure, etched forever in history. But the Earth has seen billions of years, and species, far older than us, have risen and fallen. The trilobites once filled the oceans for over 270 million years. Dinosaurs walked the Earth for more than 150 million. Humanity in its present form has existed for less than 300,000. Our written history is barely 5,000 years. In the measure of geological time, we are but a breath, and if our breath fades, the Earth will not remember us kindly. It may not remember us at all. The unsettling implication is that we may not be the first. If we vanish without leaving a clear signal, then who is to say that others did not vanish before us? Their traces erased, their voices lost in the shifting strata. We look to the rocks for confirmation, but rocks are not storytellers. They are indifferent. Imagine, then, a civilization tens of millions of years ago. Perhaps it rose in a humid age, when the continents were arranged differently. When climate and sea levels painted a world unfamiliar to us. It may have built cities, technologies, even dreams of space. And yet, when its time ended, the Earth absorbed its memory, its monuments ground into dust, its relics buried beneath volcanic flows, its bones consumed by the relentless churn of oceans. What would remain now? Perhaps nothing, or perhaps only subtle anomalies, whispers hidden in chemical ratios. Anomalies we mistake for natural quirks of geology. This is the cruel lesson of deep time. Absence of evidence is not evidence of absence. The silence of the rocks cannot confirm that we are the first. The thought is not only humbling, but terrifying. If traces of civilizations vanish so easily, then our own story may dissolve the same way. We imagine our legacy stretching endlessly into the future. Yet even the pyramids, massive in scale and enduring through thousands of years, will crumble into sand. Our greatest monuments may one day mean as little as the faint outline of a seashell in stone. The paradox deepens. We are the only known intelligence capable of reflecting on its own impermanence. Yet this very reflection reveals how fragile our permanence truly is. So future geologists millions of years from now might find no trace of us. Humanity could become as invisible as any other forgotten species. In that silence lies the heart of the great filter. If civilizations rise and fall without leaving lasting records, then the universe may be littered with ghosts. It's not physical ghosts, but entire histories lost to erosion, time, and indifference. We may not only fail to detect others, we may also fail to preserve ourselves. The scientific shock is not in imagining aliens light years away. It is in realizing that we ourselves might already be on borrowed time, that even in our triumph, we are vulnerable to the erasure of deep time. The arrogance of permanence collapses beneath the weight of geological truth. This is the silence that shakes the human soul. The silence of a world that may have held civilizations before us, may hold them after us, with none left to remember, and so the question lingers. Are we truly the first to rise on Earth, or are we only the latest? Chapter in a book whose earlier pages have already been erased. The Earth is an ancient archive. Each layer of stone is a page in its memory, pressed by oceans, carved by rivers, folded by tectonic plates. Yet unlike human records, it does not write in ink. It writes in ash and sediment, in fossil and isotope, in scars left by fire and ice. And when those pages are read with care, they tell of upheavals so violent that they reshaped the trajectory of life itself. Mass extinctions appear like punctuation marks in this history. At least 5 times in the last half-billion years, life has been brought to the edge of total collapse. Entire families of organisms vanish, leaving sudden gaps in the fossil record. 66 million years ago, an asteroid struck near what is now the Yucatan Peninsula. It released energy equivalent to billions of nuclear bombs, igniting forests, boiling seas, and filling the sky with a shroud of dust. The sunlight dimmed, photosynthesis faltered, and the great age of the dinosaurs ended. The iridium-rich layer that marks this boundary can be found in rocks around the globe, a chemical signature of catastrophe. But the asteroid was only one of many crises. 252 million years ago, at the end of the Permian, the Earth convulsed in what scientists call the Great Dying. Vast volcanic eruptions in Siberia flooded the atmosphere with carbon dioxide, triggering runaway warming, ocean acidification, and anoxia. More than 90% of all marine species and 70% of land vertebrates perished.
Ow.
In the rocks of that era, carbon isotopes reveal a world in chemical chaos. Between these great cataclysms lie subtler mysteries, long stretches of time where evolution seems stunted, or where entire ecosystems thin into silence. Fossil gaps that puzzle paleontologists. Were these merely natural pauses, the random ebb and flow of biodiversity? Or were they, as some whisper in speculation, the aftermath of interruptions, whose causes remain invisible? Earth's climate, too, has swung like a pendulum, leaving icy fingerprints across continents. Hundreds of millions of years ago, glaciers advanced nearly to the equator in events scientists call snowball Earth. Oceans froze from pole to pole, and life clung to survival in scattered refuges of liquid water. The evidence lies in ancient dropstones, boulders carried by glaciers and released into fine sediments far from their source. A geological testimony to a frozen planet, volcanoes to have written their fury into the rocks. Massive flood. Basalts, such as the Deccan Traps of India, testify to eruptions that lasted tens of thousands of years, releasing enough gas to tilt the balance of global climate. In Greenland and Antarctica, cores of ancient ice preserve traces of past atmospheres. Within them lie clues to fluctuations in carbon dioxide, methane, and even volcanic ash that fell with the snow of millennia past. If a civilization had existed, in deep time, hidden between these cataclysms, would the record of its passing resemble the scars we already see? Would its end appear as just another sudden warming, another chemical anomaly, another extinction too, easily attributed to natural causes? Modern science has begun to ask this unsettling question directly. In 2018, NASA scientists Gavin Schmidt and Adam Frank posed what they called the Silurian Hypothesis. Their thought experiment was not born of fantasy, but of rigorous curiosity. If an industrial civilization had arisen millions of years ago, would geologists today be able to detect its presence? Their conclusion was sobering. Perhaps only subtle. Traces would remain, and even those could be misinterpreted as natural events. They pointed to the Anthropocene, the epoch we ourselves are now creating. Human activity is already altering the chemical composition of Earth. Plastics are accumulating in sediments, a polymeric layer that future geologists may one day identify. Fossil fuel burning is shifting the ratio of carbon isotopes in the atmosphere and oceans. Nitrogen fertilizers have doubled the reactive nitrogen cycle, leaving signals in soils. Nuclear activity has spread isotopes never before seen in nature, some with half-lives stretching for millions of years. Together, these signatures form a kind of geological fingerprint, the mark of a technological species. But even this Anthropocene signal is fragile. 10 million years, erosion and subduction will erase much of it. Plastics may degrade into waxy residues, scattered and diluted. Radioactive isotopes will decay, leaving only faint echoes. Sediment layers will be buried, folded or melted into magma. What remains may resemble the anomalies we already find in ancient strata. Isotope spikes, chemical oddities, thin bands of unusual minerals. Are these the traces of natural cataclysms alone? Or could they be whispers of something more? Consider the Paleocene thermal maximum about 55 million years ago. In the span of just a few thousand years, global temperatures rose dramatically, oceans acidified, and carbon isotopes in sediments show a sudden influx of light carbon. Most scientists attribute this to massive volcanic activity or the release of methane clathrates from the seafloor. But its swiftness, its intensity, and its lingering mystery have led some to wonder. If we discovered this pattern millions of years from now, might we mistake it for the byproduct of industrial combustion? Or consider the abrupt disappearance of megafauna at the end of the last ice age. Mammoths, mastodons, giant ground sloths, and saber-toothed cats vanished in a geological instant. Climate change played a role, but so too did the arrival of human hunters. A species with tools and fire had left its mark not with machines, but with extinctions. Would a future geologist, 10 million years hence, recognize this as the fingerprint of intelligence, or merely as a mysterious collapse of ecosystems? The deeper we look into Earth's record, the more we see scars whose causes are not always clear. Layers of soot and sediments, spikes of mercury, sudden vanishings of species, chemical signatures out of balance. Each may be natural, or each could be something more, buried beneath the weight of time. The unsettling thought is not that the evidence is missing. It is that the evidence may already be before us, hidden in plain sight, dismissed as ordinary geology. If the Anthropocene of our time could be mistaken for volcanic upheaval or sudden methane release, then perhaps past upheavals we interpret as natural might have been something else. This reflection brings investigation full circle to search for signs of earlier civilizations. One must learn to distinguish the artificial from the natural, a nearly impossible task when time itself is the eraser. Plastics, isotopes, chemical residues, climate shifts, these are the markers we would expect of ourselves. These are the markers we already find in fragments of ancient rock, and so the deeper investigation leaves us with no clear answers. Only deeper unease. The Earth carries scars. Yes, but scars do not tell us who inflicted them. Was it asteroid, volcano, ice, or intelligence? Was it nature alone, or nature joined by minds long vanished? The rocks are silent, but silence itself is ambiguous. It can mean nothing happened, or it can mean something happened and time conspired to conceal it. The mystery grows heavier. If signs of our own civilization could one day be erased or misunderstood, then perhaps the same has already occurred. Perhaps the story of Earth has chapters erased not by chance, but by time's deliberate hand. And so the investigation deepens, not with certainty, but with suspicion. The suspicion that we may not be alone in Earth's history, that we may only be the latest flicker in a long chain of forgotten lights. What if the silence of the stars is not a warning of what may come, but a reflection of what has already happened? What if the Great Filter is not an abstract theory about alien civilizations, but a chapter already written into the hidden history of our own world? To consider this possibility is to confront an unsettling mirror. If a civilization once thrived here in some forgotten age, then it may have faced challenges not unlike our own. It may have reached a point where its ingenuity became both its power and its undoing, where the very tools that lifted it beyond survival became the instruments of its collapse. Earth's record is scarred with catastrophes, some natural, others perhaps not so easily defined. The parallels to human fragility are haunting. Climate collapse, for instance, is not a new story. The planet has warmed and cooled countless times, but never before with a species consciously fueling the fire. If another intelligence once walked this Earth, did they too alter the atmosphere beyond repair? Did they push the balance of carbon, methane, and nitrogen until the climate lurched into chaos, leaving behind only chemical traces mistaken for volcanic breath? Or perhaps their undoing came with war, not the tribal battles etched in our own early history, but a scale far more final. Humanity today lives under the shadow of nuclear fire, weapons that can erase cities in an instant and poison landscapes for millennia. If such weapons were ever wielded long ago, Would their signature not also be hidden in isotopes scattered across sediments, confused with natural anomalies? Cesium, plutonium, uranium, elements that could linger as faint whispers in the geologic archive, indistinguishable from the residue of volcanic eruptions or cosmic rays. And beyond climate and war lies an even deeper specter: technological overreach. Civilizations do not collapse only through fire and storm. They collapse through the silent weight of complexity. Rome crumbled not in a single day of invasion, but under the slow burden of infrastructure too vast to sustain, systems too fragile to endure. For an ancient civilization, the ascent into technological mastery may have carried the same risks: systems of energy, agriculture, or machines so interwoven that a single failure could unravel the whole. The Great Filter warns of such endings. It whispers that intelligence is self-limiting, that progress carries within it the seeds of ruin. When Enrico Fermi asked his famous question, "Where is everyone?" the most chilling answer was that they are gone. Not because they never existed, but because they did not last. Robin Hansen framed the filter as a universal barrier. Somewhere along the journey from chemistry to consciousness to cosmic expansion, there is a trap that almost no species escapes. The possibility that this trap has already been sprung on Earth escalates the question into something heavier. If another civilization once succumbed, then the Great Filter is no longer theoretical. It is not just a riddle of the stars. It is a scar of history, and it is not behind us. It may still lie ahead. Consider the mass extinctions once more. The asteroid at the end of the Cretaceous is often seen as random chance, an external blow from the heavens. But what of the sudden changes less clearly tied to nature? The Paleocene-Eocene thermal maximum, with its rapid warming and carbon spikes, feels eerily similar to the climate trajectory of the present. If it was natural, it warns us how delicate the Earth system is. If it was not, it hints at something more disturbing: a civilization burning fuel, altering climate, and vanishing into silence. Or the Permian extinction, when more than 90% of species perished. Massive volcanism is the accepted cause. Yet the scale of destruction resembles the ultimate failure of life's self-regulation. Was it simply magma? Or was it, in some unrecorded age, the endgame of a species that pushed too far? These are not answers, but shadows of questions. They grow darker the more we see ourselves reflected in them. Humanity today mirrors these same paths: destabilizing climate, building weapons that could erase us, creating systems so complex that we struggle to control them. We live as though permanence is our birthright, yet the Earth's past suggests otherwise. The haunting escalation is this: if the Great Filter has already claimed one civilization here, then we are not special in our vulnerability. We are simply next in line. Our silence in the cosmos is not only an external puzzle, it is a reflection of what may await us. The silence of space becomes heavier under this thought. We peer into the night sky, searching for signals, for radio waves, for alien lights, and we find nothing. Perhaps because civilizations elsewhere fall to the same fate. Perhaps because they too alter their atmospheres, unleash their wars, collapse under their inventions. And perhaps the reason we see no one out there is the same reason we may not see anyone beneath our own feet. The Great Filter is ruthless. The galaxy may be littered with ruins, visible to us, erased by time. Earth itself may have hosted a civilization whose memory is buried deeper than we can reach. If that is true, then silence is not emptiness. Silence is erasure. And so the question grows darker still. If others have already fallen here, what makes us believe we will not? If their traces are gone, what hope is there that ours will endure? The Anthropocene, with its plastics, isotopes, and chemical scars, may one day be folded into stone, indistinguishable. From anomalies of ages past, future eyes may search for us and find nothing. We, too, may vanish without memory. The escalation is not in imagining aliens across the stars. It is in realizing that the Great Filter may already be written into the DNA of intelligence itself: to think, to build, to alter, to expand. These are the qualities that create civilizations. but they may also be the very qualities that ensure their collapse. If the silence of the stars is already a silence of graves, then humanity must ask, are we living through the prelude to our own disappearance, or can we, unlike those before us, break the cycle and endure? The mystery does not resolve. It deepens, like a shadow stretching endlessly across time. The silence of the cosmos is not merely absence. It feels deliberate, as though intelligence itself carries within it a curse. From this intuition, scientists shaped a chilling idea, the Great Filter, a law that is not written in physics or chemistry, but in the fates of civilizations. It suggests that somewhere along the path from inert matter to thinking beings capable of spanning the stars, there lies a barrier that almost none survive. The Great Filter may come early, hidden in the difficulty of life itself. Perhaps the leap from chemistry to biology is so rare that Earth is a singular miracle. Or it may come later, in the fragile moment when intelligence blooms but cannot control its own power. What if the barrier is not before us, but ahead of us, waiting like a trap we cannot yet see? One model of the filter imagines self-destruction. A species invents tools powerful enough to shape its environment, and inevitably those tools become weapons. Nuclear fire is the most familiar to us devices, capable of ending cities in seconds and leaving radioactive ghosts in soil and sea. A global exchange could plunge the world into a nuclear winter, cutting off sunlight, freezing agriculture, collapsing ecosystems. In the rock record, such an apocalypse would leave isotopic scars, but after millions of years, those traces might blur into natural noise. Another form of self-destruction lies in biology. Advanced species may learn to manipulate the codes of life, engineering cures in new forms. But the same knowledge could unleash plagues, designed or accidental, that circle the globe faster than any response. Viruses or engineered microbes might leave little geological trace, erasing civilizations without marking the rocks. Artificial intelligence, too, is imagined as a filter, a creation of human ingenuity that could surpass its makers, optimizing for goals alien to survival. Whether through control of infrastructure, energy, or weapons, an intelligence indifferent to human flourishing could end the species that birthed it. Such an event might leave even less evidence than fire or plague, a collapse of systems, a vanishing of order, and then silence. Beyond self-destruction lies ecological overshoot. Life requires balance, but civilizations demand growth. A species may draw more energy, more water, more soil than its world can replenish. Ecosystems unravel, climate collapses, species vanish. The parallels to our own Anthropocene are sobering. Carbon isotopes, methane spikes, acidified oceans, all could be misread millions of years later as volcanic disturbances rather than industrial scars. If Earth has walked this path before, the record would be ambiguous, yet real. The Great Filter could also come from beyond. Cosmic catastrophes do not negotiate. A single asteroid can end an age as it did for the dinosaurs. Supervolcanoes can fill skies with ash, smothering sunlight for decades. Gamma ray bursts, cosmic jets of radiation from distant stellar deaths, could sterilize planets in moments. In these scenarios, civilizations may not fall from their own hubris, but from the indifference of the universe itself. Even the most careful, balanced, peaceful species might vanish overnight. Another possibility is evolutionary instability. Intelligence may not be an advantage across deep time. It demands vast energy, complex social structures, fragile cooperation. Perhaps most species that achieve awareness do not persist because evolution favors simplicity over complexity, instinct over reflection. In this view, civilizations rise like sparks, but sparks do not endure. The Silurian Hypothesis offers a narrower, haunting speculation. If civilizations did exist before humanity, their traces may be nearly impossible to detect. Subtle anomalies in isotopes, layers of carbon shifted out of balance, unexpected chemical residues. These signals may already be known to us, but attributed to natural causes, to volcanoes, to methane clathrates, to unexplained climate events. The hypothesis does not claim proof, but it reminds us of the humility science must carry. Absence of evidence is not proof of absence. This leads to the most unsettling speculation of all. What if Earth has already failed the Great Filter once? Ups, more than once. A civilization may have thrived in a distant age, reached beyond survival, built tools, altered its climate, and collapsed. Its memory buried under stone. If so, then the silence of the stars is not just a cosmic puzzle. It is a local warning. From a cosmic perspective, the silence grows heavier. Billions of stars older than our sun, trillions of planets, a time enough for countless civilizations to rise, and yet no signals, no great empires, no galaxies filled with light. If intelligence were stable, if civilizations endured, the universe should blaze with their presence. Its darkness suggests the opposite, that the filter is not rare, but universal. That intelligence almost always ends itself, or is ended before it spreads. This speculation folds back into humanity's fragile place in time. If the filter is behind us, if life itself is nearly impossible, then perhaps we are safe, unique, alone. But if the filter lies ahead, if the danger is in the leap from intelligence to survival, then we are walking toward our own erasure. And if Earth has already known a civilization before us, then the filter is not a theory, it is history, repeating itself. We are not pioneers. We are inheritors of a cycle that time has concealed. Speculation does not resolve the mystery. It deepens it. The Great Filter remains both a warning and a question. Are we the rare exception, destined to endure? Or are we one more voice that will fade into the silence, indistinguishable from those who may have come before? The stars offer no answer. The rocks whisper, but too faintly to be sure. What remains is the weight of possibility that the path of intelligence is not an ascent, but a fragile balance, and that the silence surrounding us is not emptiness, but the echo of countless civilizations undone. The Earth keeps its secrets in layers. To unlock them, science turns not to myth or speculation, but to tools forged in precision. Each instrument is an extension of human curiosity, reaching into stone, ice, and sky in search of whispers left. By time, the question lingers. If civilizations have risen and fallen before us, or if others wait among the stars, how would we ever know? One of the most powerful methods lies in core sampling. Scientists drill deep into the Earth, extracting cylinders of sediment and stone that serve as frozen chronicles of the past. In Greenland and Antarctica, ice cores preserve bubbles of atmosphere, tens of thousands of years old, tiny capsules of ancient air. They reveal fluctuations of carbon dioxide and methane, abrupt spikes in temperature, and layers of volcanic ash. In ocean sediments, cores stretch back millions of years, preserving pheromonophora shells whose chemical composition reflects the warmth of long-vanished seas. To the trained eye, these samples are narratives of climate swings, of extinction, events, of atmospheres in flux. If an ancient civilization altered the world, its fingerprints could be hidden here. Isotopes provide another key. The ratios of carbon, oxygen, and nitrogen reveal cycles of life and death. When humanity burns fossil fuels, it floods the air with carbon depleted in carbon-13, tilting the natural balance. This isotopic shift is measurable today, and it will leave a mark in future stone. Nuclear activity introduces isotopes unknown. In nature, cesium-137, plutonium-244, uranium-236. Some of these decay quickly, but others linger across geologic time. If traces of such isotopes appeared in ancient strata, how would we interpret them? Volcanism, cosmic rays, or something far stranger? The boundary between natural and artificial is thin, and time blurs it further. Satellites widen the scope. Orbiting above Earth, they are not merely eyes on the present, but recorders of change. Instruments like NASA's OCO2 measure carbon dioxide across the globe, revealing the breadth of forests, the emissions of cities, the circulation of oceans. Landsat satellites track the spread of deserts, the retreat of glaciers, the growth of megacities. Radar satellites peer beneath clouds, tracing the rise and fall of land. These machines chart the Anthropocene as it unfolds, mapping the signal that humanity is etching into the planet. And by extension, they teach us what signs we might seek on other worlds. Astrobiology extends this search outward. Traditional quest of Satya, the search for extraterrestrial intelligence, once listened only for radio waves. Faint whispers of communication drifting through space. But silence greeted those ears. Today, the definition of a technosignature has grown. Scientists search for industrial pollutants in exoplanet atmospheres, traces of chlorofluorocarbons or nitrogen oxides that biology alone cannot produce. They study light curves of distant stars, watching for unnatural dimming that might hint at vast structures. They search for waste heat, the infrared glow of civilizations harnessing stellar energy. Each of these methods expands the net, seeking not only voices but footprints, shadows, scars. The same logic folds back onto Earth. If humanity vanished, could a distant observer detect us? Would our greenhouse gases be visible across the light years? Would our night side glow with the faint illumination of cities? Would our satellites form a ring detectable as a narrow band of debris? And if so, could we ourselves not search for similar anomalies in Earth's own deep past? Technosignatures are not limited to the sky. They may be hidden in geology, sudden spike of plastic polymers, a layer infused with industrial soot, a chemical cocktail that no volcano could brew. The Silurian Hypothesis suggests that such signals may already be buried beneath our feet. Yet the challenge is daunting. How do we distinguish the artificial from the natural? A sudden warming event could be industry, or it could be methane clathrates erupting from the seafloor. A surge in carbon dioxide could be combustion, or it could be volcanism. Science demands caution, and so speculation bends toward nature. But absence of certainty does not erase possibility. The debates continue. Some argue that Earth has never borne another civilization, that the anomalies in the record all have natural explanations. Others counter that time erases too efficiently, and that humility demands an open mind. After all, even our own Anthropocene signal is fragile. 10 million years hence, it may resemble nothing more than a blurred chemical hiccup, indistinguishable from events already catalogued. The same puzzle confronts us in exoplanet science. When a telescope detects carbon dioxide or methane around a distant world, is it life? Is it industry? Or is it merely volcanism, geochemistry, chance? New missions push the boundaries of this uncertainty. The James Webb Space Telescope, with its infrared vision, is beginning to analyze the atmospheres of exoplanets, searching for disequilibrium, combinations of gases that do not persist without life or technology. Future telescopes like the proposed LOVOIR or HABEX observatories may take direct images of Earth-like worlds, scrutinizing them for pale blue dots that whisper of oceans, continents, and perhaps civilizations. Particle colliders probe the fundamental laws of physics, testing whether the universe itself harbors stability or hidden dangers. Cosmic surveys map the background radiation, searching for clues to cosmic inflation, dark matter, and dark energy. Each tool in its own way is part of the same investigation. Are we alone? Or are we the latest in a sequence of intelligences? Work is ongoing, and it carries weight beyond science. For to study the signals of intelligence elsewhere is to reflect on our own fragility. To imagine isotopic fingerprints buried in stone is to imagine our own fingerprints fading. To scan the stars for pollutants or lights is to ask whether our own pollutants and lights will endure long enough to be seen. The tools of science are careful. They do not leap to conclusions. They measure, they test, they compare. But even as they tread cautiously, they reveal a truth too large to ignore. Intelligence leaves marks in air, in stone, in light. Yet those marks are temporary. The planet recycles itself. Cosmos erases. What remains after enough time is silence. And so the testing continues. Cores are drilled, telescopes launched, signals parsed. The question is not answered. It is sharpened. If a planet has hosted intelligence, How would we ever know? And if Earth itself has known it before, how could we prove it now? Science does not settle the mystery, it refines it. It forces humanity to look deeper, to question its permanence, to admit that certainty is fragile.
Oh.
The rocks are silent, but silence itself is a data point. The sky is empty, but emptiness too is a signal. What lies behind both is the same haunting. Possibility that intelligence is fleeting, that civilizations are fragile, and that even as we search, we may already be vanishing into the record we cannot yet read. If the great filter is real, then every step humanity takes is also a question. Each invention, each choice, each century of survival asks whether we are moving closer to escape or closer to erasure. The silence of the cosmos does not simply confront us with mystery. It confronts us with a mirror. Perhaps this silence is the whisper of civilizations that came before us, on distant planets circling other stars, or here on the same soil that carries us now. If intelligence once flourished and fell in forgotten ages, then our place in time is smaller than we imagine. We are not the inevitable summit of life, but one fragile moment in a chain that may already have broken more than once. The possibility unsettles the human spirit, because permanence has long been our illusion. We build monuments of stone and towers of steel, convinced that they will outlast the ages. We preserve our words in books, in digital clouds, in archives buried deep underground, yet the earth has no obligation to remember. Its oceans grind, mountains into sand. Its tectonic plates swallow continents whole. Its glaciers carve valleys and erase cities. To Earth, a million years is no more than a season. And in such seasons, civilizations are brief sparks. This reflection forces humility. Dinosaurs walked the Earth for 150 million years, a reign incomprehensibly longer than the entire history of humanity. Yet they are gone, remembered only in scattered fossils. We have built our global civilization in less than 10,000 years. Our written record is younger than the oldest trees still standing. The arrogance of permanence dissolves under this scale. We are ancient only to ourselves, but fragility is not hopelessness. It is clarity, reveals that survival is not guaranteed, and that survival itself is precious. If the great filter lies ahead, it is not a prophecy but a warning, a reminder that intelligence without wisdom becomes its own undoing, that growth without balance consumes its foundation, that progress without reflection becomes a path to silence. The thought extends beyond Earth. If we vanish, the universe continues. Stars will burn, galaxies will collide, black holes will grow. The cosmos does not need us to endure. Yet in all the vastness we have observed, no other intelligence has announced itself. No voices, no cities of light, no networks spanning the stars. If there are others, they are hidden. If there were others, they are gone. This leaves humanity with a burden that is also a gift, perhaps. We are the only chance for the universe to know itself through thought. Carl Sagan once wrote that. We are a way for the cosmos to know itself. The reflection is profound. If we fall, that knowing may fall with us. If we endure, that knowing may spread among the stars. The silence suggests that endurance is rare, but rarity does not mean impossibility. The possibility that Earth once held another intelligence magnifies this reflection. If they lived and died here, then the filter is not a riddle of distant galaxies. It is carved into the very planet we call home. It means we are not unique in rising, only in continuing. And it leaves us with a haunting uncertainty. Are we approaching the same end that erased them? Or have we already passed through the trap they could not escape? The paradox deepens. If humanity is early, then the great filter lies behind us. Perhaps life itself is so unlikely that Earth is alone in carrying it this far. If humanity is late, then the filter lies ahead, waiting. In one case, we are miraculous. In the other, we are doomed. Both possibilities reshape how we see ourselves, and yet, the silence also carries an invitation. It invites us to choose differently, to study the scars of Earth and the emptiness of the stars, and to learn that survival is not only biology but wisdom, to recognize that permanence is not given but earned, to realize that our greatest monuments are not cities or machines but the continuation of thought itself. Even if we vanish, the universe will not pause. But if we endure, we may become its storytellers, its memory keepers, its voice carried across the void. The stars are waiting. They do not tell us whether the filter is behind or ahead. They do not reveal whether we are the first or the last. They only shine, indifferent and eternal. While we wrestle with the fragility of our moment, and so the final reflection rests not in certainty, but in possibility. Humanity may not be the first and may not be the last. The arrogance of permanence must give way to humility, and humility to responsibility. The silence of the universe is haunting, but it is also a canvas. What we do now will decide whether we too fade into that silence or whether we carry the light of thought beyond it. The stars wait, and the question remains, are we walking toward the filter that ends us, or have we already passed through it without knowing and become the rarest of all things, a civilization with a future?